Hello students, welcome to the class of Digital Communication Lab. So in the last class, we have seen the QPSK modulation, which was the extension of BPSK modulation. And today we are going to see the FSK modulation, that is frequency shift keying. Actually, this is the binary FSK modulation. So in first, let's say this is the digital signal. This is the pattern of 1010, and the FSK signal looks like this. We are just the corresponding to 1 there is a higher frequency, and corresponding to 0 there is a lower frequency. There is only two types of frequencies present here, corresponding to 1 and corresponding to 0. So this is FSK, actually the extension of FM. So in FM there is a speech signal or some other signals also including, but in FSK there is the series of 1 zeros only. So this is in binary, and the FM was in analog. So let's see to the block diagram. For generation of FSK there is two types. Only here you can see there is a master signal, 2 kilohertz digital clock has been given to the sequence generator, and you already know how the sequence generator works. And the switch is to 00 because NRZL coding is used. Here that output of this 10 pattern has been given to CRO, and this output pattern has been given to VCO. This is VCO block in the Emona Telecom Trainer 101. So what is the work of VCO? It generates the frequency. This is voltage controlled oscillator. It generates the frequency according to the voltage. When we vary the voltage of this VCO, it generates the frequency corresponding to it. So if we are giving the input to this VCO, that is a pattern of 10 and 1010, that is only we are giving the two level of voltage to this VCO. So it's actually generating the only two level of frequencies, and that is the FSK modulated signal. And one other way we can modulate the signal is by just multiplying the frequency. For as when it is 0, multiply by other frequency, and it is 1 multiplied by some other frequency. But that two type of frequencies we can not multiply here. There is a limitation in this Emona kit. So this basically there is two types we can generate the FSK signal. So in which the first one I will use. So as this master signal 2 kilohertz clock frequency has given, this clock frequency is given to just operate the sequence generator, and it generated the bits, binary bits, which is an RZL coding. This can be shown in CRO, and this input has been going to VCO module, and it converts the input that is binary series 1010 pattern to FSK signal. So let's see. This is master signal. I have given 2 kilohertz digital signal from this way to the clock of sequence generator, and I have put this switch to 00 that generates an RZL coding, and here a line code has been generated. I have given this line code to the CRO channel 1, as well as this line code has been given to the VCO. You can see this is VCO, voltage control oscillator. So there is two types of frequencies, in which frequency you are going to generate the frequency. This is high and low. I have just switched to low, and this is the input of VCO, and this is the sine wave which is generated by this VCO, and this sine wave has been generated according to the input given, that is according to the voltage input given, because it is a voltage control oscillator. And I have shown this on the CRO. So for your I have just pressed auto set. It is generating the, to see clearly, let's press single. Yes. So You can see this is 0, and corresponding to 0 there is a low frequency component present here, and this is 1, and corresponding to 1 there is high frequency present, and then again for 0 this same frequency component has been repeated, and for 1 this higher frequency frequency has been repeated. So basically it looks like this. For 0 for 1 this is higher frequency, for 0 this is lower frequency. This is the FSK signal, modulated signal, which can be sent. The advantage of FSK signal is it reduces the noise which is adding in the amplitude, because we modulate the signal of message signal in the frequency, and if the amplitude has been distorted, or noise has been added to the amplitude, then we can limit the amplitude, and we can just get the original signal by simply. So this is the advantage of FSK. So this was the first part, which is generation of FSK. Let's come to the second part, that is demodulation of FSK. So for the demodulation part, there is two frequency component present in the modulated signal. So we have to choose one at a time. So for that purpose, we are going to pass it through tunable low pass filter. So the output of the VCO now is passed through tunable low pass filter, and the tunable low pass filter output now I am going to show you on the CRO. So I have given output. So you can see the tunable low pass filter output looks like something this. So here this is 1010, but you are unable to see how this looks like. So I can just press single. It is basically whole signal. In this modulator signal, both the frequency present. So we have to extract one. So for that, you have to tune this tunable low pass filter to low frequency. That's why the higher frequency component has passed out to 0. So this is full range. Now I'm going to decrease it, and you can see the effect. So this is 0. Once more I'm going to press it. Yeah, you can see one frequency component is going to be 0. Now you can just say single and adjust the amplitude of this. So yes, you can see there is 0. Corresponding to 0 there is frequency present. 1, this frequency has been cancelled or rolled out. You can clearly see by this way, this frequency has been 0, and for corresponding to 0 this is frequency is remaining. So I have just chosen one frequency, and by this way you can select one frequency for demodulation. So for demodulation, let's see the block diagram. There is a digital signal, and this is the FSK generated signal. This is the demodulation which I have passed through the tunable low pass filter. Now this is not the demodulated signal, so you have to use the envelope detector. So for the envelope detector, you can use here in this circuit there is no envelope detector is present, as you can see. So at the place of envelope detector you can use the rectifier which is present here, and as well as the baseband low pass filter. By combining this, envelope detector is formed. So to use the envelope detector, I have given the output of this tunable low pass filter to this rectifier, input, and the output of this rectifier I have given the baseband low pass filter. The output of baseband low pass filter has given to CRO. So this is basically this is envelope detector. The output of an envelope detector you can see in the CRO, but let's see. So you can see there is so many distortion available in the output. Here you can see this is corresponding to 1, this is corresponding to 0, this is corresponding to 1, but there is distortion. This is not actually equal to the our modulated signal. So to overcome this this effect, we can just pass through it the comparator, as you have already seen in the PPSK and QPSK. The comparator is used for to correct the digital signal. So for comparator, there is a comparator. I have to give the output of this baseband low pass filter to the comparator input first. Let's see. So now I have given the baseband low pass filter to the comparator input, this, and the reference of this comparator is given by VCC. So this two input and output of the comparator has been given to CRO. There is fluctuation. Yes, as you can see the result. Yes. So exactly this is some delayed version of this our input signal. This is same as our input signal. The output is getting the same. So this is because you can tune the VCC to correct way to get the exact replica of this output signal. So what we have done in this experiment, first we have generated the FSK signal, which is I have given the 2 kilohertz digital signal to the clock of sequence generator. Then the clock of then the generator line output has been given to CRO, as well as it is given to the VCO, which is the voltage control oscillator. According to the given input, it is generated the sine wave, which is the FSK modulated signal. I have given so I have shown the FSK modulated signal. In the demodulation part, I have given this FSK modulated signal to the tunable low pass filter input. Then output of this tunable low pass filter has been gone to the rectifier, and the output of rectifier is gone to the baseband low pass filter. And these rectifier and baseband low pass filter combined, actually acts as a envelope detector. The output of baseband low pass filter is now given to the comparator to get the exact output which I have given the input. So the comparator reference is given at the VCC, and we can tune the VCC by using this switch, and the output has been obtained. So basically this was the experiment of FSK. Here I want to tell you one more thing, that I have used this type of things. There is a why every time there is a question. This is I'll show you why this is fluctuating. So there is a trigger, external trigger signal, which can be synchronized to this synchronization to remove actually this, but it is so old apparatus, that's why it is so triggering. So you can just press single to get this. So basically in this triggering is fault of CRO, and this is very old. So thank you guys. We will meet in the next lab in offline mode. So this is, I think, was the last lab in online mode.